In this episode, we begin with an idea that quietly shapes a huge amount of modern security work, even though beginners do not always realize how often it is happening behind the scenes. Integrating application programming interfaces, APIs, and plugins for efficiency is really about helping different security tools, data sources, and workflows connect so analysts do not waste time doing the same repetitive tasks by hand all day. For someone studying CompTIA CSA+, the value of this topic is not memorizing software product names or learning how to write code for every platform. The real value is understanding why connected systems make security teams faster, more consistent, and better able to respond when something suspicious happens. A modern defender often works in an environment with many separate tools for alerts, identity, endpoints, email, logs, assets, tickets, intelligence, and reporting, and if those systems do not communicate well, the analyst becomes the one manually carrying information from place to place. Once you see that problem clearly, integration stops sounding like a technical luxury and starts looking like a practical necessity for efficient security operations. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good place to start is by understanding what an API and a plugin actually are in simple terms. An API is a structured way for one system to request data from another system, send data to it, or ask it to perform a defined action in a predictable format. A plugin is usually a smaller extension or connector that allows a tool or platform to add a specific capability, often by helping it interact with another service more easily than building everything from scratch. The relationship between the two is important because a plugin may use an API behind the scenes, even if the analyst only sees the result as a new button, a new workflow step, or a new source of context inside an existing platform. For beginners, the easiest way to think about this is that APIs provide the communication rules, while plugins often provide the ready-made bridge or extension that makes those rules useful inside everyday operations. Together, they help separate tools behave more like parts of one working system instead of isolated islands that force analysts to jump constantly between screens and manually reassemble the same case details every time. This matters so much because security work is naturally fragmented when tools are deployed one by one over time. An organization may have an endpoint tool that sees device activity, an identity platform that sees login behavior, an email system that sees suspicious messages, a case management tool that tracks investigations, and an intelligence source that adds outside context. Each of those tools may do its own job reasonably well, but the analyst still loses time if none of them share information cleanly. Without integration, a suspicious alert may require someone to open several consoles, copy an address or username, search for recent related activity, check asset ownership, compare with threat intelligence, and then manually type the results into a case. That approach is slow, tiring, and inconsistent, especially during high alert volume or when analysts are working under pressure. Integration helps solve that problem by allowing information to flow more directly between systems, which reduces the number of separate manual lookups needed before meaningful analysis can even begin. In practical terms, efficiency improves because the team spends less time moving data and more time interpreting what the data means. API integration becomes especially powerful when you think about how much security work depends on repeated context gathering. A raw alert often starts with very little meaning on its own. A suspicious domain, a user account, a file hash, or an unusual sign-in might appear in one tool, but the analyst usually needs more information before deciding whether the event matters. Through API connections, that one detail can be sent to other systems, so the case is enriched with asset data, recent login history, related alerts, threat intelligence, user role information, or past case activity without requiring the analyst to search each source manually. This does not magically solve the investigation, but it changes the starting point. Instead of beginning with a thin, isolated signal, the analyst begins with a more connected picture. That picture is often what allows faster triage, better prioritization, and more consistent decision-making, because the essential supporting facts are gathered in a structured way rather than only when an individual analyst happens to remember where to look and how many systems must be checked. Plugins add another layer of efficiency because they allow organizations to extend a tool's usefulness without rebuilding the platform itself. A plugin may add threat intelligence lookups to a case view, allow quick connection to a ticketing system, enrich alerts with asset ownership, support messaging to another team, or help one platform trigger action in another. From the analyst's perspective, the plugin often feels like an extra capability inside the main tool they already use, which means less screen switching and less context loss during an investigation. This matters more than it may sound at first, because every time an analyst has to leave one system, search somewhere else, and then mentally reconnect the information, there is friction. Friction slows work, increases fatigue, and makes mistakes more likely. A well-designed plugin reduces that friction by bringing useful capabilities into the workflow at the moment they are needed. For a beginner, that is the central idea to remember. Plugins are valuable not because they are flashy extensions, but because they help the workflow stay intact while still pulling in the extra context or action needed to move the investigation forward efficiently. One of the biggest operational benefits of integrating APIs and plugins is consistency. When information is gathered the same way every time, the team is more likely to produce similar quality across similar cases, regardless of which analyst is on shift. Without integration, one analyst may check all the right sources while another checks only some of them, either because of time pressure or because the process depends too much on individual habit. An integrated workflow can automatically attach baseline context to every case of a certain type, making sure important facts are available from the start. That does not eliminate human judgment, but it creates a more stable foundation for that judgment. Consistency also improves reporting because the same categories of information are more likely to be present in every case. Over time, this makes it easier for managers to see patterns, improve workflows, and train new staff, since the process is not hidden inside the memory of a few experienced people. In security operations, efficiency is not only about doing things faster. It is also about doing them in a way that is repeatable and dependable when pressure increases. A simple example helps make the topic much easier to picture. Imagine a user reports a suspicious email that appears to come from a vendor, and the analyst needs to decide quickly whether it is a harmless message, a phishing attempt, or part of a wider campaign. In a disconnected environment, the analyst may need to review the message in one tool, search for related delivery in another, look up the sender domain in a separate intelligence source, check whether any users clicked links in a different platform, and then create or update the case manually. In an integrated environment, the reporting tool, email system, intelligence source, and case platform can share information through APIs and plugins so the case is enriched automatically with much of that context. The analyst then begins with a fuller picture, including who received the message, whether similar messages exist elsewhere, whether the domain has a suspicious reputation, and what user activity followed. The investigation still requires thought, but the first several minutes of repeated manual effort are compressed into a faster, more reliable flow. Another common example involves vulnerability management, where efficiency depends heavily on combining information from many places. A scanner may identify a flaw, but that result alone does not always tell the team how urgently the issue should be addressed. Through integration, the vulnerability finding can be combined with asset data, business criticality, exposure to the internet, recent threat intelligence, compensating controls, and whether active exploitation is being reported elsewhere. A plugin may surface some of this context directly inside the vulnerability platform, while API connections may supply it from inventory systems, intelligence providers, or case management tools. This changes the decision from a narrow technical question into a more realistic security question. Instead of asking only whether a flaw exists, the team can ask whether it exists on an important system, whether that system is exposed, whether attackers are using the weakness in the real world, and whether the organization has reason to believe the issue could be abused soon. Efficiency improves because prioritization becomes more informed without forcing analysts to chase every piece of context manually from separate systems. Integration also supports automation, but it is important to understand the order of operations. A process should first be clear enough that the organization knows what information needs to move, what decisions are being supported, and what actions are safe to perform consistently. Once that is understood, APIs and plugins can help automate parts of the process by pulling data, updating records, creating cases, sending notifications, or triggering follow-on tasks. This is where efficiency becomes much more visible, because repeated steps stop, depending entirely on human repetition. Still, the value comes from thoughtful automation, not from automating everything simply because the connection exists. A workflow that automatically gathers context and recommends a case priority may be highly useful, while a workflow that automatically takes disruptive action without enough evidence can create new problems. Beginners should remember that integration makes automation possible, but it does not make automation wise by default. The workflow still has to be designed with care, and the human analyst still remains essential wherever uncertainty, business nuance, or significant operational risk is involved. Security teams must also think carefully about the risks that come with integration, because every new connection between systems creates both value and responsibility. If a plugin or API connection has too much access, poor oversight, or weak authentication, it can become a new pathway for misuse, error, or compromise. This is why least privilege matters in integration just as much as it matters in user access. A connection should have only the permissions needed to perform its intended function, not broad rights simply because that is easier to configure. Teams also need to think about what happens when the connected system fails, sends incomplete data, or changes how it structures information. If analysts trust the integration blindly, they may miss the fact that an expected enrichment failed or that a field changed in a way that breaks the workflow silently. Efficient integration is therefore not just about connecting systems. It is also about managing access carefully, validating results, planning for failure, and making sure the people using the workflow understand what the connection is supposed to do and where its limits begin. Data quality is another major factor in whether integration truly helps or merely creates a polished form of confusion. When separate tools use different field names, different time formats, different asset labels, or different severity logic, connecting them may not immediately create clarity. It may instead create mismatched records, duplicated events, or context that appears helpful but is actually misleading. This is why normalization matters so much. The organization has to think about how data from one tool should be interpreted in another and whether the meaning remains consistent as it moves through the workflow. A well-designed integration does not simply move data faster. It helps make the data more usable by preserving meaning and reducing ambiguity. For a beginner, this is an important lesson because efficiency is not just about speed. If data moves quickly but arrives in a form that confuses the analyst or distorts the case, then the workflow is not truly efficient. Real efficiency means the right information arrives in the right place with enough clarity to support a better decision, not merely a faster transfer. Another misconception worth challenging is the idea that integration is mainly a technical project for engineers and has little to do with analysts. In reality, analysts often understand the workflow pain points better than anyone else because they live inside the friction every day. They know which lookups are repeated constantly, which context is always missing at the start of a case, which handoffs lose detail, and which tools force too much manual copying of the same values. That operational knowledge is essential for good integration design. A technically elegant API connection that moves data no analyst needs is less useful than a simple plugin that saves 30 seconds on every phishing review across hundreds of cases. For CISA Plus learners, this matters because the exam mindset is not only about knowing technical definitions. It is also about understanding why processes succeed or fail inside real operations. Analysts who grasp integration concepts can help improve workflows, identify useful automation opportunities, and communicate more clearly with engineers or administrators who build the technical side of those connections. As organizations grow, integrated tools also help security functions work together more effectively. The Security Operations Center, SOC, vulnerability management, incident response, threat intelligence, identity teams, and management often depend on overlapping data, but use different systems and different rhythms of work. APIs and plugins help reduce the barriers between those groups by allowing information to move in more structured ways rather than relying entirely on emails, chats, or manually copied reports. A suspicious login can become a case with asset context attached. A vulnerability can be escalated with business impact already present, or a threat intelligence update can enrich related alerts automatically, so the SOC knows what to check first. This makes the broader security program more cohesive. Efficiency at that level is not just about individual productivity. It is about reducing delays between teams, improving shared visibility, and making it easier for one part of the organization's defensive effort to support another part without unnecessary friction or loss of context along the way. What ties the whole subject together is that integration helps security teams spend more of their limited energy on analysis and less on movement. A disconnected environment forces analysts to act like translators, messengers, and manual data processors before they can even begin to think about the actual risk in front of them. Integrating APIs and plugins changes that by connecting systems so the right data can appear at the right time in the right place, supporting faster triage, better enrichment, more consistent case handling, and smoother coordination across tools and teams. For a beginner, that is the most important way to understand efficiency in this context. It is not about technical elegance for its own sake. It is about reducing avoidable friction so defenders can use their time where it matters most, which is interpreting evidence, making sound decisions, and responding appropriately to real security concerns rather than spending their day manually stitching together information that machines could have shared for them. By the end of this discussion, integrating APIs and plugins for efficiency should feel much more practical and much less abstract than it may have at the start. APIs provide the structured communication that lets systems exchange data and actions reliably, while plugins often bring those capabilities into everyday workflows in a way analysts can use directly. Together, they help reduce manual effort, improve consistency, enrich investigations, and support more connected security operations. They also require discipline, because access control, failure handling, and data quality must all be managed carefully if the integration is going to help rather than hurt. For someone preparing for CISA+, the key takeaway is that modern security work depends heavily on connected tools, not because connection is fashionable, but because disconnected tools waste time and weaken analysis. Once you understand that, you can see why effective integration is such a major part of building a security program that is scalable, responsive, and able to operate efficiently under real-world pressure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.